right, now the fun job. Setting up the proportions. We look at example 5. How would we set that up? Again, what's your corresponding sides? You guys really get to look at these and use your spatial skills. What corresponds to what? All right, so we're going to use 6 over 9. How do you know that those two correspond together?
They're both between the angle and
Yes, they're both between the two angles. Okay, good. Now what?
then it would be 5 over x.
5 over x. You know? So remember, you're going to keep that same order. You did left over right equals left over right. Okay, then how do we solve this? 6x equals 45. X is 45 sixths. Which is what? What about example 6? This is called the side splitter theorem. Right? That was one of the websites you guys are supposed to go to. What did you learn from the side splitter? How would you set up this proportion?
X over 4,
Uh-huh.
and then x plus 3 over 2.
And I'm going to do a different proportion, Sarah, but yes, you have that set up correct. On this problem, the way I'm going to always tell you guys to do it is think about squeezing it. Think about the pinchers. These two, and then these two. Okay? So the way you're going to do this is, but again, you want to make sure your parts are lining up. If I'm going to do it this way, I usually take the side over the base. So I'm going to do 6 over 4. Is equal to my side over the base. So x plus 3 over x. Now, Sarah, you said yours differently, right?
Yeah, I still got like the same thing.
Yeah, okay. Sarah, tell me what yours was. You said x over...
Yeah, x over 4 and x plus 3 over 6.
So x over 4 and x plus 3 over 6. Well, this is a great question. Which one do we write down? Well, let's take a look at this. With proportions, what do you do when you solve? You got to cross multiply, right? If I cross multiply here, I get 6x equals 4 times x plus 3. What do I get down here? 6x equals 4 times x plus 3. So again, it doesn't matter how you set up your proportions as long as you set them up correctly. You're going to get the same cross products. Alright, so the way that a lot of you guys set up your problems on your homework tonight might not be the same way that I'll model it for you tomorrow. But what's important is that you get the same cross products. So I get 6x equals 4 times x plus 3. Or x plus 12. All right, questions on that? You're told that the triangles are similar. How would I solve for x and y in this problem? Careful how you set this up, otherwise you get yourself into the tight corners here. What do you guys think? Axel?
10 over 6 would equal y over 12, which would also equal x over
Well, let's verify. How do you know that the 10 matches up with the 6?
Just look right.
There's an easier way to do it than that.
Are they
But
mirrored?
You're right. That's right.
The way that it says EDF is
There you go. Go back to the similarity ratio or the statement. You have to have your corresponding parts lined up. Therefore, DE corresponds to AE. So DE is the 6, corresponds to AB, which is 10. So you can use the statement to line up your corresponding parts that you're given the statement. All right, so let's solve these individually. So we have 10 over 6 equals y over 12. Okay, so how do I solve for y? Y is 20.
Yes.
Okay, how do I solve for x? Okay, now, notice here, a lot of you guys maybe wanted to use the 20 over 12. I would always go back to your guarantee. Okay, always go back to what you're given and use that instead of your newfound values. Sometimes you have to use the newfound values, but if you can, always go back to your guaranteed values. So we use the 10 over 6. So 6x equals 90. X is 50. Now number 8. All right, so this unit, the similarity unit, and the right triangles unit, I will probably make myself an enemy in the math department by stating this. These are probably your most useful 2 units out of this entire course. If you ask anyone who doesn't realize they're using geometry, but they're using it out of this unit, and they're using it out of the right triangles unit. Okay, let's be honest, most of us aren't using a lot of circles.
No.
Okay? I don't think a lot of us are dealing a lot with parallel lines and all the stuff that comes out of that. So when you think about similar triangles, you know, this is actually a really easy way to do some really basic math. Right? And this is something that I remember having to do it in the Boy Scouts. We did the whole stuff in the woods, and we actually had to figure out, you know, how tall a tree was, not just for random purposes, but you know, there's actually something else we had to do. We didn't know how tall the tree was before we were able to do it. And so this is a very simple problem. And it's basically very common. You're going to see this on a lot of college entrance tests. I've seen it on the ECA. You'll probably definitely see it on the new park assessment. It's just called a shadow problem. And it's similar to triangles. And basically, if you take the ratio of the height to shadow, that will be the same no matter what object you're measuring. Unless you're measuring at the same time of day. Okay, so don't go measure your shadow at 7 and then go measure another shadow at noon. It's not going to work. They're going to get the same time of day. Okay, so we have a man that is 2 meters tall. And he casts a shadow that is 6 meters long. And then we want to know how tall our building is. Call that T, or you can use H for height. Not use H. Over. If I were to kind of diagram this for you, you can imagine there's our man, and he is 2 meters tall, casting 6 meter shadow. And then we have this really, really tall building who's casting 36 meter shadow. And then when we look at this, you think about creating the triangle from their relative shapes. Now we can somewhat see how those are similar. And they both have a right angle. And this angle right here is called the angle of declination. It's not something you guys need to know for this course. It's basically called the sun angle. And that's why it's really important if you're going to do this problem, actually outside this classroom, it's really important that you do it in relatively the same amount of time. Right, a couple of minutes isn't going to make that big of a difference in your measurements. Waiting an hour or so will. Okay, so it really depends on the sun's angle in the sky. And that's basically how we get then angle. So these are similar triangles. And so we need to figure out then the height in our building. So one thing that I would always suggest to you guys is always to reduce the fraction if you can. I know we did not on the previous problem, but if you can reduce it, I definitely would. So how does 2/6 reduce? 1/3 equals h over. Okay, so if we cross multiply, so we get 36 is equal to 3h. H is 12. So how tall is our building? 12 meters. All right, that's pretty much it.